Hello everyone, welcome back to Diksha Karnataka YouTube channel, and you are watching Decode NCERT series where we are trying to understand the NCERT book. So if you are following this series from the beginning, you know the rules. First of all, you have to open the NCERT book and then you have to follow with me so that you can complete the chapter quickly and fast, because exams are approaching and you don't have the time to read the entire book. And so far we have completed up to optical fiber from this chapter. Now we are going to discuss about refraction at spherical surfaces and bilens. So this will be our topic, and along with that we will also discuss about the optical instruments. So be with us till we complete this chapter. So this will be the last part of this chapter, so quickly we will complete. So first let's see what we are discussing about: refraction at a spherical surface. Spherical surface means concave surface, convex surface, it can be any surfaces, but it is refraction, not reflection. We have seen reflection in spherical mirrors. Now we are talking about refraction. So here as you can see, a ray of light is traveling, it is a spherical surface, it is a second medium, and light ray is completely going into the second medium of this spherical surface. So you can consider this to be a water surface, or it can be a glass surface, whatever it is. After light is traveling through this, so this is the U, this is the V. Okay, for spherical surfaces there is nothing as such focal length. Focal length is there for mirrors, focal length is there for lens, but what is the focal length for a spherical surface? There is no as such point of focal length for a spherical surface, but we know the radius of curvature. Okay, so radius of curvature is for a spherical surface is given. So using that we can find the derivation. The derivation I have done in my class, which I think is slightly easier than the way they have given. It is slightly tricky to understand. From this you can check my Brahmastra series where I have done this derivation, and the formula is N2 by V. How to remember which one is what? So I told you the formula is that this is N1, okay, and this is N2, okay, and this is very similar to that of the lens equation. Okay, so N2 by V minus N1 by U. So in case of lens equation, 1 by V minus 1 by U. So in this case N2 by V. So N2 by V means wherever V is, if you remember in the spherical surface, V was in the second medium, right? So we have seen that this is the spherical surface and V was in the second medium. This was our second medium, and there is an object which is after refraction, it is falling here. So this was our V. So V is in the second medium, right, N2, and U was in our first medium, N1, right? So from there we can say that N2 by V, so N2 divided by V minus N1 divided by U. So U is in our first medium, so N1 divided by U is equal to N2 minus N1 divided by R. So this is the formula that you should remember, easy to remember. Now based on this formula some numerical questions might come, but the derivation is very important. A numerical question might come for KCET exam. I have not seen any numerical question from only spherical surface form for your board exam, but KCET exam might be important. Okay, in KCET exam might be some question might come from this. And obviously the main derivation of this chapter, that is don't go ahead. So this is the lens maker's formula. The derivation is very important. Okay, very important, not only important, is very important. It's most commonly asked question from this chapter. Again, the derivation is done in my Brahmastra series. You can check that out, and this is very common derivation. 1 by F is equal to N minus 1 by R1 minus 1 by R2. So here in most cases this is basically air, okay, and R1 is equals to R2. So most cases R1 is equal to R2, but the sign is different. So for example, in case of convex mirror, okay, the convex lens, this is positive, this is negative, so total sign becomes positive. Okay, in case of concave mirror, this is positive, this is negative, so total sign becomes negative, right? Concave lens, sorry, again I am just still in the hangover of mirrors. So anyway, so this is the most common formula and most commonly asked equation and used equation. Numerical questions, theory questions, all can come from this formula, and from there the lens equation, obviously 1 by v minus 1 by u, and according to the sign convention, as I mentioned, that v can be positive, v can be negative based on the condition, but u will always be negative. So even though there is a negative sign, you have to put that negative sign here whenever you are trying to find u. Okay, in case v is given, f is given, you are trying to calculate u, don't put the value, don't put the sign of u, the sign will come automatically. For any unknown quantity, you don't need to put the sign. For any known quantity, you have to put the sign, so that after calculation, unknown quantity will come out with a proper sign. You don't have to worry about it, the proper sign will automatically come if you apply the sign for the known quantities. Okay, now double concave or convex lens are equidistant from the optical center. The focus of the side of the original source of light is called the first focal point, whereas the other side is called the second focal point. So you know that a lens basically means that, so a lens basically has two surfaces, right? One surface is this, another surface is this, right? So and it's an equiconvex lens. So if parallel rays falling from this side, this is the original side from where the light is falling, so the light are concentrating here. Okay, so this is the first focal point, principal focal point. Okay, now if you reverse the path, that is, if you allow the light to travel from opposite side, so if you allow some light to travel from this side, so they will also converge at some point on this side. So this is the secondary secondary focal point or second focal point. Okay, secondary focal point or second focal point, this is the primary focus or first focus. Okay, so this word you have to remember. Okay, now these are the very important concept regarding lenses. Similar concepts are there for concave lens also. So as you can see, primary focus or first focus of convex lens is positive, whereas secondary focus is negative. But we do not use secondary focus, we always use primary focus, because our object is always located on the left hand side. But here also we have two focal lengths for a given lens, and both are primary focus, but one is first primary focus, one is second primary focus. Okay, and as usual, if the rays are parallel, they will they will concentrate on a plane that is called focal plane. Focal plane is same as that of the mirrors, but even though they are not super important concepts in terms of understanding, I have not seen any application of focal plane in anywhere other than the practical applications are there, but question wise application I have not seen. Okay, now as usual, in case of focal ray optics or ray diagram also, we have to consider two rays to draw a diagram in case of convex lens or concave lens. Okay, the first ray is obviously parallel to the principal axis and it will pass through the focus, and the second ray is passing through the optical center of the lens, it will go undeviated. So these are the two main rays that we need to consider. Third ray, they have shown it that is not super important. Okay, same thing is there for concave mirror also, concave lens also. Okay, in case of concave lens, obviously the image is virtual. Now the magnification is given by m is equal to v by u. Okay, so magnification is basically v by u for lens, and here also as usual you have to use the sign. So in case u is negative, v is negative, then those negative sign will cancel each other and m will turn out to be positive. Now there is a small thing that you have always remember, that if m is negative, overall value of m is negative in case of mirror, or be it in case of mirror, be it in case of lenses. If m is negative, that represents a real image. Why? Because negative means it represents a inverted image. So inverted image only happens when the object, the image is virtual. You are not listening to me. That's why I'm trying to trick you. So remember that whenever m is negative, the image is real, whereas whenever m is positive, the image is erect. That represent image is erect. Erect image means it is a virtual image. So always remember that. Okay, that is a one important trick for competitive examinations. Okay. Now the power of P of a lens is defined as the tangent of the angle by which it converges or diverges a beam of light parallel to the principal axis falling at unit distance from the optical center is given by. So this is the P is equal to 1 by F. Now in this formula you have to be careful. F is represented in meters. Very careful. If F is given in centimeters, then the power formula becomes 100 by F. This is very important to remember, especially for solving problems in competitive exam, as well as one problem I have solved during my lectures. So that is also a common problem, might come from this chapter. So to solve such questions you have to use this. If F is given in meters, then this formula is fine. If F is given in centimeters, remember either you convert meter to centimeter and then solve, or you use this formula. The unit of power is given by diopter and it is basically meter inverse. Okay, clear? So now combination of lenses in contact, again derivation is not important, only thing is the final formula. So when two lenses are in contact, the focal length is given by 1 by f1 plus 1 by f2. So you can write like the parallel combination of resistors, you can write it here f1 f2 by f1 plus f2. This is a shortcut formula, you can remember, or you can use this formula, no matter whatever is comfortable with you. And in terms of power, powers just get added. If you are considering two lenses in contact, you are trying to find the total power, it will be the sum of all the powers, P1 plus P2 plus P3 plus P4. Okay, you remember that. Easy. And in case of magnification gets multiplied. So you have to careful, because sometimes some objective MCQ questions might come from this depth as well. Even though very easy, students sometimes gets confused, so you have to be ready for that. Now let's move into the refraction through prism. Now this diagram you have seen that. Okay, and geometry, using geometry you can prove that that there are few things that you can prove. First of all, you can prove that the angle of deviation, not minimum deviation. Angle of deviation is basically angle of incidence plus angle of emergence minus angle of prism. Angle of prism is basically the top angle. This angle is called angle of prism. Okay, this angle is called angle of prism A. Okay, so this is the angle, the top angle. So always we consider this is the base. So whenever the light ray is entering, with respect to which it is entering the prism, that is considered to be the base. If you rotate the prism, if the prism is not equilateral, if you rotate the prism, then definitely based on the side through which the light is entering, the angle of the prism will change. But that depth of question again I have not seen in any the exam, but you should know it. Now if you plot the angle of deviation versus incident angle, okay, this is a practical graph, this is an empirical graph. Empirical graph means it is obtained from experiments. Okay, and this is not directly done from any theory or any equation. It is done by changing the angle of incidence and measuring the angle of deviation. Okay, there is a way to do it. We have done it when I was doing my bachelor's in physics honors. So that experiment was there. You have to draw this graph and you have to show that this angle of deviation is basically at some angle of incident and angle of emergence are actually getting equal. That means basically at this point you can see that the graph is having a lowest point. So lowest point means this is the minimum deviation, this is the minimum angle of deviation, right? So this is the minimum angle of deviation, and from that you can say that okay, minimum deviation happens only when angle of incidence is equals to angle of emergence. Okay, for any other point, angle of incident and angle of emergent has to have the two different values. Okay, and at angle of minimum deviation, because the incident angle and emergent angles are equal, so the two inner angles should also be equal, and from there you can say that the refracted angle, the angle inside the prism must be equals to a by 2, and from there you can calculate the refractive index of the prism. Okay, which is basically sine A delta m by 2 divided by sine A by 2. The derivation also I have done in my class. And in case of a thin prism means the angle of the prism is very, very small, less than 10 degrees. So you can approximate that to be, you can approximate sine theta to be equals to theta. So it becomes A delta m by 2, and it becomes A by 2. So basically you get delta m is equal to n2 minus 1 into A. So in this case it is exactly independent of anything. It only depends directly only on the angle of prism. Okay. So also it represents makes sense that thin prism does not deviate the light much. Now optical instruments, let's move on to the optical instrument part. So optical instrument, what are the optical instruments? We have microscope, okay, we have telescopes. So first we will start with microscope. Simple microscope means a simple convex lens. Simple microscope is only a single convex lens. Okay. Compound microscopes are having something which is more than one lens. Okay. Now the magnification in case of a microscope is given by m is equal to d by f. Okay. So now according to our sign convention, V is negative and it's equal to in the magnitude to D, thus the magnification is given by 1 plus D by F. Okay. So here D is the minimum distance of distinct vision, okay, from where you are seeing the object. Okay, so this is how you can see. So be careful to solve this question. Once I have seen this question came as an MCQ question, so be ready. If you see these questions, you can answer it. Okay, and in case of small angle, so they have mentioned that as the clear from the figure, the angular magnification is given by D by F. Okay, if the angle subtended by the eye in the image, then object, if the object is very, very far, okay, final object, final image, okay, so angle subtended is very, very small. So in that case you get the magnification to be directly D by F. And this is a compound microscope. Okay, in case of compound microscope, you have used in your biology lab if you are a bio student. Okay, the microscope that you use to see that inside of onions, okay, that cuttings of stem. So this is a compound microscope where you have a objective lens and there is an eyepiece. Objective lens is the lens which is facing the slide, okay, the petri dish, and the through which you are observing is basically connected to eye. So that means this is the eyepiece. Whatever is facing the object is objective, whatever is facing your eye is the eyepiece. So eyepiece through which you are seeing, and objective through which the light enters the microscope. Okay, so this is why you can see an inverted, very large inverted image through the compound microscope. So basically it can enlarge, zoom the microscope. Basically also if you change the objective, you have seen there is a 10x, there is a 40x, there is a 100x microscope, right? So based on the objective you can change. The eyepiece cannot be changed, obviously eyepiece has a fixed focal length, but you can change the objective to change the focal length. So these are also point of objective question. So which one you will change to increase the size of the image formed in a compound microscope, objective lens or eyepiece? You have to change the objective lens. Be careful, be mindful about this. Again the magnification is same formula given by 1 plus d by fe. When the final image is formed at infinity, so if the image is very far, then the angular magnification is given by d by fe. Okay, fe is the focal length of the eyepiece. So focal length of the eyepiece is important. So based on the focal length of eyepiece, you can see that the magnification, right? And here they have added the focal length of eyepiece and the objective. So this is the total focal length. Okay, so total focal length is L by f naught into d by fe. Okay, so based on the so generally the magnification of the eyepiece remains constant. Magnification of the objective you can change based on the focal length. If you decrease the focal length, the magnification increases. So you can see that you can make up to 250 times brighter and enlarged image of the object if you see it properly. Now microscope helps us to see small object which is closer to us, whereas telescope helps us to see bigger object but which is very far away from us, and thus they are appearing very small. So that is the role of telescope. Telescope is which is helping us to see bigger objects but very far object. Okay, and whereas microscope helps us to see smaller object but closer to us. Okay, so this is the basic difference between a microscope. Micro, the term comes from the term that is small. Tele means which is far. Okay, so telescope is used to see distant objects. So as you can see here also we have an objective, we have an eyepiece. Okay, so this is the focal length of objective, this is the focal length of eyepiece, and total length of the telescope basically sum of the focal length of objective and focal length of eyepiece. Okay, now let's see what is the observability says. So this is a part from where question came in the last year. So let's understand this paragraph clearly. Advantages and disadvantages of lenses. Okay, different types of telescopes. First, big lenses tend to be very heavy and therefore difficult to make and support by their edges. So we know that lenses, if you have seen the lenses, we use a peripheral, a circular ring. Inside that the lens is embedded, then we have a handle. So this is a small lens. Now to observe a very small object located say billions of light years away, you need a huge lens. Okay, one such lens is installed in the Hubble Space Telescope. Because of that it can see different objects, right? So it is an optical telescope. Okay, so the lens required to make such huge lenses is very difficult because you only get the rim to support it. Okay, the ring itself will take a lot of space and it has to be heavy. So making big lenses is very difficult. Okay, so that is why one of the disadvantage of the refracting telescope. So the telescope which are made using lenses are called refracting because they are refracting the light, right? So this is called the refraction. So the refracting telescope, one of the main problem is that glass telescopes are very huge, so it is very difficult to mount them. Okay, further it is rather difficult and expensive to make such large size lenses which form images that free from any kind of chromatic aberrations and distortions. So one main problem about refracting lenses is that different colors refract by different angles. Okay, so if you consider a say a convex lens, okay, mainly convex lenses are used as you have seen in the telescopes. So suppose I am using a red light. Okay, let me use the color so it will be helpful for you. So red light, suppose entering the lens, okay, it will get refracted. It will get refracted and converge at some point. Okay, and suppose I am using a yellow light. Okay, after falling on the lens, it will converge somewhere at a different point. Now we know that the white light consists of 7 colors. So all the 7 colors, they all get refracted by different angle, and all of them get combined at different points. So all the colors, you will, instead of getting the exact image, you will get a yellow image, you will get a red image, you will get a blue image. So different colorful images you will get. So that is one of the major problem of the refracting telescopes, that you have to have different position to measure the same object. This is possible, quite possible. We have achieved that. There are different filters are used, different color filters are used at a random rate, so that you get all the colors corrected and then you can measure them. So that is fine, but it's expensive. It is very expensive to make such arrangement, and also making such big lenses. Big lenses means very big of chromatic aberration. Chromatic means colorful. Okay, chrome comes from the term color. So chromatic means you will get a colorful image instead of getting a proper image that you are looking for. Okay, so and also if they overlap over each other, the image will be actually blurry. So after the data is collected, after the image is collected, a lot of post processing is required, and that is why it is very expensive. Whereas if you use spherical mirrors, due to reflection, all the colors reflect by the same amount. Reflection does not change the angle, so all the light reflects by the same amount, irrespective of their color, because the medium is not being changed, right? So this is one of the biggest advantage of the spherical mirrors. Similarly, spherical mirrors do not require only the rim part, they can be supported from the bottom. So if you draw a spherical mirror, okay, you can support it from the bottom part. Okay, so entire bottom part can be used to support the mirror. So that is why you can make large spherical mirrors easily without much difficulty. Okay, so spherical mirrors can be constructed larger compared to lenses. Secondly, there is no chromatic aberrations for spherical mirrors. That's why spherical mirrors are preferred over lenses while constructing telescopes. So this was the question came in last year exam. So it was like an assertion reason based question, that spherical mirrors are preferred over lenses because they are easy to fit. Number two, they don't have chromatic aberration. Both are correct, both are wrong, like that. The question was there. So if you have seen my Brahmastra series, I have covered that question. Anyway, so that's why this is the question that is being asked. I have discussed it. Here it is one of the example of the reflecting telescope. So this is an arrangement where light is falling onto the telescope, and after reflecting, one problem of the spherical mirrors are that the light gets reflected inside the tube. Okay, in case of refractive telescope, why refractive telescopes was huge? Because you just put one lens in the front, one lens in the back, and you can see through your eyes. Okay, but in case of spherical mirrors, the light will be reflected and they will convert somewhere inside the tube. If you are making a tube, you will not be able to see anything through the tube. So what you have to do, you have to put some arrangement like this. This was an old arrangement done by Cassegrainian telescope. The name of the telescope is Cassegrainian telescope, name after the inventor Cassegrain. So this is one of the way to see the object through the eyepiece. But nowadays, if you see a Cassegrain telescope generally have an eyepiece which is mounted on the body of the telescope. If you see through the body, you will be able to see. So they have a different arrangement. They have some hole over here. The mirror is rotated such that the reflected rays comes over here, and you can see through this hole. So they have modified this design. This is one of the oldest design, but still you can convert a spherical mirror like this, and you can still measure, you can still see all the objects in the sky. And all the modern telescopes are basically spherical mirrors. So there are all different optical telescopes are there. One of them is in Aries, in Aryabhatta Institute of Radio Astronomy and Telescope. So there is a optical telescope. You can go and check it out on internet. If you are interested, you can study there in future if you qualify their exam. Okay, right? So this is, they have just mentioned that the largest reflecting telescope in the world is a pair of Keck telescopes in the Hawaii, USA, which is a reflector of 10 meter in diameter. Okay, 10 meter in diameter, that you can imagine, it's a very huge telescope, 10 meter in diameter. Okay, so you can imagine 1 meter scale, it is 10 times that. Okay, so 1 meter scale that you used in your laboratory to measure distances, etc. So it is 10 times that distance, and that is the diameter. So it is a huge telescope, because that you have to draw a circle using that to understand the size of that, right? Even a 5 meter telescope is very considered to be huge. Okay, now if you want more information, you can study about Hubble's telescope, and you can find out what is the diameter of Hubble's telescope, and you will understand the difference between that. More the size, bigger the size, more light will come. More light coming means we can draw a more clear picture of a very distant star. So these are the main advantages. Okay, and another disadvantage is that you cannot put the telescope into the space. Bigger telescopes are not be able to are not usable in the space. You have to put a lot of effort to put it in the space. So always space telescopes are smaller, okay, but efficient, whereas earth based telescopes can be made as big as you want, but they can only be used at night time, because during the daytime sun is there, so he is blocking our vision, so you cannot see anything whatever outside the sun's coloring things. So only at night time you can see the sky. Also it has to be a remote place away from all the light sources, so that no light interferes with the image that you are observing. Okay, there are other ways to observe during the daytime. One of them is radio telescope. If you are interested, you can search radio telescope. There is a huge radio telescope array in Pune, Maharashtra. You can research about that as well. So I will conclude my chapter here, and I will be back with the wave optics chapter in our next class. Till then, bye.